Hello everyone. In this video we are going to be considering the modulus. The modulus is also called the absolute value of a function, and the basic definition is the length. The modulus is a measure of length. The absolute value of the modulus is represented by two straight lines because it's a measure of length. For example, if the absolute value of x is equal to 5, what this tells us is that if I take a measure of the length of x, I'm going to arrive at 5. So this is a number line. I've got a 5 to the right of 0 and a negative 5 to the left of 0. So clearly, if I have my ruler on the 0 mark, I'm going to see that at this point of 5 is going to be the modulus, which is 5. If I do a similar thing and I take my ruler from the 0 mark from right to left, I'm also going to see that the distance between 0 and negative 5 is also going to measure 5. So the length is 5 irrespective of the direction. So from 0 to 5 measures a length of 5. From 0 to negative 5 also measures a length of 5. Thus, I can conclude that if the absolute value of x is equal to 5, what it tells us is that the length of x is going to be 5 from 0 to 5, and it's also going to be 5 from 0 to negative 5. In conclusion, the absolute value of x equal to 5 could mean two things. It could mean that x is equal to 5 or x is equal to negative 5. Thus, the absolute value of 5 is 5 and the absolute value of negative 5 is also 5. So this tells us that the absolute value is a positive value. It doesn't matter if we have a negative between the two bars, we are always going to have positive results. So this is a very specific case. Now let's take it to a more general level. The absolute value of x is greater than a. So here we have it. We've got a positive value of x greater than a. And of course, a is a constant. It could be a positive number, it could be a negative number, it could be fraction, it could be whole number, and so on and so forth. Now, by definition, we know that absolute values are positive values. So if this is a number line where every point here represents values of x, and I've got a 0 here, and a to the right of 0, and a negative a to the left of 0. Now we are told that the absolute value of x is greater than a. So this means that the length we need here in consideration is greater than a. So if the length is greater than a, what it means is that if I have my ruler on the 0 mark, my range of values would be all of the numbers that are beyond a. Similarly, if I do the same, if I have my ruler on the 0 mark and I take a measurement in order to obtain the values that are greater than a, I would see that every number that is beyond negative a to the left would also make the cut. So this tells us that the absolute value of x greater than a implies two things. First, these are numbers that are greater than positive a, as we can see here, and are less than negative a. So this is the definition of the absolute value of x greater than a. The next one is going to be the absolute value of x less than a. So also we can also have the number line. This is the 0 mark. A is to the right of it. Negative a is to the left of it. Now, so our interest here are all of the values, the length of x, that are less than a. So the length is less than a. So if we have our ruler here at the point 0, we are going to see that the ruler is going to measure A at this point. So all of the numbers that are between 0 and A meet the cut. And similarly, with our ruler here at 0 and we are measuring from right to left, we are going to see that all of these numbers between 0 and negative A would also meet this condition. Thus, we can see that the absolute value of x less than A also implies two things. One, the values of x are less than positive A and they are greater than negative A. For example, if A is 3, then negative A is going to be negative 3. And we can see that all of the numbers between 0 and negative 3 are greater than negative 3. And since we know that x greater than negative A is the same as negative A less than x, we can combine these inequalities to arrive at this definition. The absolute value of x less than A implies that negative A is less than x and x is less than positive A. This is the definition of the absolute value of x less than A. And of course, as we found earlier, the absolute value of x greater than A can be defined as x greater than positive A, x less than negative A. It's an or here. So this is the definition of the absolute value of x greater than A. We can just adopt these two definitions for greater than or equal to or less than or equal to. So for example, the absolute value of x less or equal to A is just going to be negative A less or equal to x less or equal to positive A. And also, if the absolute value of x is greater than or equal to A, what it means is that x is greater than or equal to A, or x is less than or equal to negative. Let's take a few examples. The first one, if the absolute value of x is greater than 5. So here we can see that this is very similar to the absolute value of x greater than A. And we have the definition here. If the absolute value of x is greater than A, what it means is that x is greater than A or x is less than negative A. Thus, the absolute value of x greater than 5. Here is going to be the solution. X is going to be greater than 5 or x less than negative 5. And we can see that this makes lots of sense, because if this is a number line representing x and we are told that the values of x are greater than 5, then if this is 0, 5, and a negative 5, now all of the values to the right of 5 are greater than 5. And if we have our ruler here, this is 5, this is going to be a length of 5. All of the numbers left of negative 5 would also give a measure that's greater than 5. So we can see, and the numbers here are all less than negative 5, and the numbers to the right of 5 are all greater than 5. Let's take another one. Absolute value of 2x greater than 3. So, of course, the first thing we are going to do here is to compare. This is a greater than, so we are going to compare this with the absolute value of x greater than A. And we know that this is x greater than A or x less than negative A. So this is just going to be 2x greater than 3 or 2x less than negative 3. So solving this one, I'm just going to have to divide both sides by 2. The inequality is not going to change because 2 is a positive number. So x is going to be greater than 3 over 2, or solving this, x less than negative 3 over 2. So if I plot the number line, we would see that the first one, x greater than 3 over 2, so, and x less than negative 3 over 2, we can see all of the values to the left of negative 3 over 2. And as usual, using our ruler metaphor, we would find that if the ruler is here, all of the numbers between 0 and 3 over 2 are less than 3 over 2. So we can see that the numbers to the right form a part of the solution. And also, the numbers to the left of negative 3 over 2 are all less than negative 3 over 2. So this is this, and this is this. Let's take example 3. The absolute value of x plus 1 is less or equal to 4. So to solve this, we are going to have to compare this problem to absolute value of x. This is a less or equal to a, and we know the definition of this. If the absolute value of x is less than or equal to a, what it means is that negative a is less or equal to x less or equal to a. So whatever is within the two lines will be treated as a single entity. So this is going to imply that x plus 1 is going to be less or equal to 4 and would have a negative 4 here. So the absolute value of x plus 1 less than or equal to 4 is negative 4 less than or equal to x plus 1 less than or equal to 4. So this is a combined inequality that we can detach. If we detach this, we're going to have negative 4 less than or equal to x plus 1. And here we would have x plus 1 less or equal to 4. But as usual, we know what this is. This is the same as x plus 1 greater than or equal to negative 4. Why is this so? We know that 2 is less than 3. So if I want to have 3 before 2, I'm going to be having a greater than. So if negative 4 is less than or equal to x plus 1, then x plus 1 is going to be greater or equal to negative 4. So we are going to solve each one. Solving the first one here, we're going to have x greater than or equal to negative 4, negative 1. So this is x greater or equal to negative 5. Then the second one, so here is a solution. Then or x plus 1 less or equal to 4 is just going to be x less or equal to 4 minus 1. This is x less or equal to 3. Therefore, the solution of this inequality is x greater or equal to negative 5 or x less or equal to 3. Let's take a final one. If the absolute value of 3x minus 4 is greater than 2, then by definition, we are going to have to compare this with absolute value of x greater than a. And if the absolute value of x is greater than a, the meaning is that x is going to be greater than a, or x is going to be less than negative a. Thus, we are going to treat what's within the two lines as a single item. So it means that the absolute value of 3x minus 4 greater than 2 would be 3x minus 4 greater than 2, or this second one, 3x minus 4 less than a minus 2. So we are going to solve each one in turn. So solving this one, we would have 3x greater than 2 plus 4, 3x greater than 6, and x is greater than 6 over 3, that's 2. The inequality symbol is not going to change. And here we have 3x less than negative 2 plus 4. This is 3x less than plus 2, and x is less than 2 over 3. So we can combine both inequalities. If x is greater than 2, what it means is that 2 is less than x. So we can combine 2 less than x and x less than 2 over 3. So this is just going to be 2 less than x less than 2 over 3. This is the solution of the inequality, the absolute value of 3x minus 4 greater than 2. If you find this video useful, kindly like, share, drop a comment, and do not forget to subscribe. Thank you for watching. See you in the next video.